Hi, today we're going to start section 10.1. Chapter 10 is all about circles. So let's start with the definition of a circle. It is the locus or set of all points in a plane equidistant from a given point called the center. Think about a circle, you guys. If this is the center of the circle and this is your circle around it, all of the points on the circle are going to be the same distance away from the center. This distance and this distance and this distance and this distance, all these will be the same length. That's what it's talking about there. A circle is named two ways. You can either draw the symbol, which is a circle with a dot in the middle, and then you use the center letter. So in this particular circle that you see over here on your right, C is the center, so you can write circle C with the symbol, or you can also write circle C with the word. Those are the two ways to name this particular circle. You always use the point that is located at the center of the circle. A radius is a segment with endpoints at the center and on the circle. So a radius goes halfway across a circle. For instance, if I look right here on our picture, CE is a radius, CF is a radius, CD is a radius. It doesn't really matter what letter you put first. You could also call this same radius CD or DC. But it is a segment. So when you name a radius on a circle, you want to use the segment bar above it. So some examples are CD, CE, segment CE, and segment CF. Those are all examples of segments that are on the circle, in this particular circle. A chord. A chord is a segment with endpoints on the circle. So if I was going to use our picture here, I'll just erase my markings. A chord is going to go from one side of the circle to the other side of the circle, but it does not have to go through the center. So an example of a chord in our picture here would be segment AB. This is a chord. It goes from one point on the circle to another point on the circle. Now DE does that as well. It starts at one point on the circle and goes to another point on the circle. That is technically a chord, but it is a special chord. Because it goes through the center, DE is not only known as a chord, but it's also known as a diameter. A diameter is a segment with endpoints on the circle that passes through the center, and it's made up of two radii. So in this picture, DE is the only diameter that's drawn in on the picture. Okay, so go ahead and pause the video here and see if you can fill in parts A and B of this example. So as you can see, I did part A here, and just to check your work, this would be called circle P. You could have also written out the word circle and then used the letter P. There are three radii that you could have listed. Plural for radius is radii, just like cactus, cacti, octopus, octopi, fungus, fungi. So radius, radii. Radii is the plural. The diameter is LN, and notice all the segment bars above these answers, and a good chord would be segment MN. You could have also used segment LN in this case. So go ahead and pause the video again if you need to and do part B. And as you can see, I've filled in part B. Go ahead and check your work. Remember to put those segment bars on there. If you forget those on the quiz, it would be a half a point off. So you have to have that little symbol above the segment. As I mentioned, a radius is half as long as a diameter. A diameter goes all the way across a circle through the center, and a radius will go halfway across the circle. And so if QV is 4, the distance from Q to V is 4, what would the diameter of this circle be? Well, it would just be double, so it would be 8. If your segment TU has a distance of 14 feet, what would the radius of the circle be? Well, 14 TU is the diameter, so you cut that in half or divide by 2 to get the radius. So 7 feet would be the radius of the circle, half as much if you're going halfway across. Congruent circles. So one thing you need to know is if you have two circles where the radii are congruent, then the circles will be congruent. Remember, congruent means that they are exactly the same size, same shape. So in this example, if segment GH is congruent to segment JK, then circle G will be congruent to circle J. I like that. That's a good geometry sentence right there. So if the radii are the same length, then the circles are congruent. Concentric circles is a term you should know. Concentric circles are coplanar circles that have the same center. In other words, it's like a bullseye. It's like circles inside of circles. The problem with concentric circles is sometimes it's hard to tell. Like if I was just going to have you look at this picture right here and say, oh, do you see circle A? You might have a hard time explaining what circle I'm talking about. So when you have concentric circles, you have to write something like this. Circle A with radius AB, segment AB. Now you know which circle I'm talking about. I'm talking about the smaller circle. I could also write circle A with radius AC. And then you would be able to tell that I'm talking about the bigger circle. So technically both of them are circle A, but when they're concentric circles, you should be more specific by using the radius. Take a look here. You can see in this first little box on the left that these circles intersect each other. And these particular circles have 2 points of intersection. Oops. Meaning they intersect in one spot, 2 spots. These circles intersect in 1 spot, 2 spot. The next box, you can see they have 1 point of intersection. And finally, this last box, there aren't any points of intersection. So no points of intersection. Could you draw 2 circles that have 3 points of intersection? Why don't you go ahead and pause the video and try that. Try to draw 2 circles that intersect in 3 spots. If you've been trying, you probably have figured out you can't do it. Try to draw 2 circles that have 4 points of intersection. If you try to draw a circle and another circle that have 4 points of intersection, I don't think you're going to be able to do it. The only other scenario besides the ones that you see here are if you happened to have 2 circles that were exactly on top of each other, then they would have infinitely many points of intersection. But other than that, your only other options are 2 points of intersection, 1 point of intersection, and no points of intersection. You can never get 3 points or 4 points or any other number. Let's move on to something a little different now. The diameter of circle S is 30 units. That means all the way across from here to here is 30 units. Halfway across would be 15. The diameter of circle R is 20 units. So all the way across circle R is 20, which means halfway across, like from here to here, would be 10. And from D to S is 9. So this distance over here is 9 between D and S. Find CD. Well, as you know, halfway across the bigger circle is 15. So from S, from right here to right here is 15. So what if we took the 15 and we subtracted the 9 out of there? We would have 6 left, and 6 would be the distance right here from C to D, because the 6 plus the 9 have to add up to 15. So 6 units is CD. Let's try another one. The diameter of circle X is 22. So all the way across circle X is 22, which means halfway across is 11. The diameter of circle Y is 16, which means halfway across is 8. If we go halfway across Y. From W to Z is 5, so we'll put that in there, a little 5, and we want to find X, Y. There are many ways to do this one. One way is you could figure out the distance from x to w by doing 11 minus 5. 11 minus 5 would leave 6 for xw. This plus this have to equal 11. You could also figure out the distance from z to y if you do 8 minus 5. This distance over here would have to be 3 because 5 plus 3 add up to 8. So now to get the distance from x to y, we have many options. We could do 6 plus 5 plus 3. That comes out to be 14. We could also do the distance is 11 plus 3, which is 14. We could also do, let's see, we could do 6 plus 8, which is 14. So basically you want to add all the distances between the x and the y. So 14 units is your answer. You could use any of these choices to get there. You only have to do one way, not all three ways. Take a look at these circles. Imagine that I find the distance around one of the circles, and I divide it by the distance across the circle. Does anybody know how many times the diameter will go into that circumference? Think about distance around the circle. How many times would the diameter divide into it? Distance around the circle, how many diameters would divide into it? If you said 3.14 times, you are correct. So what happens is the distance around the circle is called the circumference. And if you divide that by the diameter, it will always be exactly 3.1415926 and so on and so on and so on. It will be pi times. So let's devise the formula for circumference. Think back, circumference divided by diameter is pi. So if I want to solve this for c, if I multiply by d on both sides, these would cancel out. Circumference is pi times d. Or in other words, circumference is diameter times pi. Since a diameter is the same as 2 radii, you can sometimes see the circumference written as 2 pi r as well. The 2 and the r would be the same as 1 diameter. So real quick, remember, if your diameter is 10, what's your radius? 5. If your radius is 5x, what's your diameter? 10x. I just want you to remember the radius is always half as much as your diameter. Okay, so keep these formulas in mind. I tend to use circumference equals diameter times pi quite a bit, but really both of these formulas are just fine. Use the one that you like. RT is 10. So take a look at the picture. RT is a diameter. It goes through the center of the circle. Find the circumference of the circle. So circumference, if you recall, is diameter times pi. In this case, our diameter is 10, so it's 10 times pi. If we want the exact circumference, we leave it 10 pi. If we want the rounded circumference, we actually can type it into our calculator then. We would type in 10 and then pi. Be sure to find the pi button. I do not want you to use 3.14. I want you to actually use the pi button on your calculator. Depending on your calculator, the button will change. If you have a TI-30, there's actually a button for it. If you have a TI-84, it's probably above one of the buttons, and you might have to use second to get to it. So find your pi button, type in 10 times pi. If you did it correctly, you should get about 31.42. I'm rounding it to the nearest hundredth. So the exact value cannot be rounded at all. The rounded value, you're going to round off. Let's do it to the hundredth. 2 decimal places would be great. Let's try another one. Find the circumference of a circle with a radius of 2.5 centimeters. So if your radius is 2.5, your diameter is twice as much. It would be 5. Circumference is diameter times pi. So 5 times pi. 5 pi would be your exact circumference. And I guess we should label that centimeters. If we want the rounded answer, we're going to type 5 pi into our calculator. Go ahead and do that. If you're doing it correctly, you should get 15.71 centimeters. That is the rounded answer. Let's try one more. Find the circumference of a circle with diameter of 16. So remember, circumference is diameter times pi. So it's going to be 16 pi. Type it into your calculator. The rounded answer should be 50.27. And both of these can be labeled feet. Oh boy, an asteroid hit Earth and created a huge round crater. Scientists measure the distance around the crater at 78.5 miles. What's the diameter of the crater? So they measured around this thing, and the circumference was 78.5 miles. And we have to figure out what's the diameter. Well, remember, circumference is diameter times pi. The 78.5 goes in for the c. We don't know the diameter. Pi can stay pi. If I want to solve it for diameter, I'm going to have to divide by pi. I would grab my calculator, type in 78.5 divided by pi. Go ahead and do that. If you did it correctly, you should get 24.99 miles. And that would be your final answer. That's a big crater. A series of crop circles was discovered in Alberta, Canada on September 4th, 1999. The largest of the 3 circles had a radius of 30. Find the circumference. All right, think about that, you guys. If the radius is 30, what's the diameter? If you said 60, you're right. Remember, circumference is diameter times pi. So you're going to do 60 times pi. Punch it in your calculator. Might as well get a decimal answer for this one, I think. And if you did it correctly, the circumference is 188.5 feet. And that would be the circumference around the biggest circle in the field. Find the diameter and the radius of a circle to the nearest hundredth if the circumference is 65.4 feet. This is a good one. You want to know how to work backwards on these. The circumference is 65.4. That's what they're giving us. Remember, circumference is diameter times pi. Where do you plug the 65.4 in? For the c. So you're going to go 65.4 equals diameter times pi. How do you solve it? You're going to divide by pi. Whatever you do on one side of your equation, do on the other. Those will cancel out. Type it in your calculator, 65.4 divided by pi, and you should get 20.82 is D, and that would be feet. But read the question carefully. It says find the diameter and the radius. How do we get the radius? Well, you're just going to take 20.82 and cut it in half, and so that ends up being 10.41 feet. Oops, that's a T. Inscribed and circumscribed. So if a polygon is inscribed in something like a circle, it's going to be inside of it. So in this case, we have a quadrilateral and it is inscribed in the circle. Notice all the corners of the quadrilateral touch exactly on the circle. The circle, however, is circumscribed about the quadrilateral, which means it's on the outside of the quadrilateral. So inscribed means inscribed, circumscribed means outside. Before we start number 14, please take a minute, at the most a minute, and fill in really quickly the list of perfect squares. You may not use a calculator. You may not use Google or Siri. I want you to use your brain. Fill in as many of these as quick as you can. Pause the video, and then ready, go. My guess is most of you got this far and then started having a little trouble. You probably have 1 through 12 already memorized. Your job now is to memorize the rest. So I'll go ahead and fill them in, and then you can check and see if you get the right answers. So just like when you memorized your times tables, by memorizing these perfect squares, your math is just going to go faster. And so I highly recommend that you memorize these 20 perfect squares. Here's why. Number 14, you have a square with side length of 9 inches inscribed in circle J, which means you have a square inside of the circle. If it's a square, all the sides of it will be the same length, and so they will all be 9 inches. Our job is, it says, find the exact circumference of the circle. Circumference is diameter times pi. We need this diameter. Some of you might see that we can do Pythagorean theorem. We could do 9 squared plus 9 squared equals diameter squared. 81 plus 81 equals diameter squared. 162, if you add them together, take the square root, and this is where you run into some trouble. It says they want the exact circumference. You cannot have a decimal. That would not be exact, or you cannot have a non-repeating decimal. So you need to figure out, can you break down 162 anymore? And you can. 81 actually goes into this twice. So the square root of 81 and the square root of 2, if you think of 81 times 2, that's the same as 162. The thing is, the square root of 81 is 9. The square root of 2 is not a nice number. So we just figured out the diameter of this circle is 9 root 2. Did anybody realize that this was actually a 45, 45, 90 triangle in here and think, oh, if I have a 45, 45, 90, I can take the leg times root 2 to get the hypotenuse? Ha, you still get 9 root 2, don't you? So our diameter is 9 root 2, but that is not our answer. So to get the circumference, we're going to take 9 root 2 and we're going to multiply by pi. So our final answer would be 9 pi root 2, and we have a label. It is inches. That is an exact answer. If I would have multiplied 9 times root 2 and gotten a decimal, it would no longer have been exact. Let's try another one. Find the exact circumference of this circle. Remember, circumference is diameter times pi. We need to figure out what the diameter is. In this case, we have 2 radii that are part of a triangle. So these 2 sides are the same length, which means we end up with a 45, 45, 90 triangle again. So we could, to find one of the legs, we could take 3 root 2 and divide by root 2 and get 3. Both of those would be 3. The other way you could have done it, if you can't remember that 45, 45, 90 stuff, is you could have done x squared plus x squared equals 3 root 2 squared. This gets a little tricky. This is 2x squared, and then over here when you square, you have to square both things. So it's 9, and then the square root of 2 squared is 2. So we have 2x squared equals 18. Divide by 2. X squared equals 9. Square root. X equals 3. Both of them a little tricky. Bottom line is, we now know the radius is 3, therefore the diameter is 6. Find the exact circumference. Circumference is going to be 6 times pi. I don't think there's a label here. It wants the exact answer, so we're going to leave pi as part of our answer. We're not going to type it into our calculator because then it would no longer be exact. Last but not least, find the exact circumference of a circle with a circumscribed square. Think about this. The square is circumscribed around the circle. So in this case, we're going to have a circle with a square on the outside. I'll read it again. Find the exact circumference of a circle with a circumscribed square that has side lengths of 10 feet. So there's our square. It has side lengths of... So the question says, find the exact circumference of the circle. So remember, the circle or circumference is diameter times pi. We need to know the diameter of this circle. Well, diameter is going to go from one side of the circle to the other through the center. So this would be a diameter. If we just take this 10 feet and slide it up, this will also be 10 feet. So the diameter is 10. 10 times pi would be the circumference. It does say it wants the exact circumference, so it's 10 pi feet. We do not type it into our calculator because they want exact. All right, go ahead and try the 10.1 homework. If you have questions, let me know.